Hello there, and welcome to another video. I recommend that when you try to modify your code to use the stuff I teach you today, you should do so into a copy of your code from last time, because these modifications, if done improperly, could ruin your code. So I would not want to make these modifications into the only working copy of a program that I had. Today, I will introduce you to our topic by suggesting that we modify our game so that each enemy has a name that prints followed by a colon and the phrase "ouch" when that enemy is killed. Note that we cannot just add a string to the int array that has until now represented the enemy, because it can only hold ints and not strings. While we could solve this problem using a separate array list of strings and set up both array lists so that the first enemy spawned in has its coordinates at index 0 of the int array list, and its name at index 0 of the string array list, and the second enemy spawned has its coordinates at index 1 of the int array list, and its name at index 1 of the string array list. However, this would not be very readable for the programmer. Note that when I refer to readability from now on, I'm referring to how easy it is for the programmer to read something. Everything would be much simpler if we did not have to use int arrays, the collections of variables that can only hold ints, and we could instead use collections of variables we design ourselves to hold 2 ints and 1 string. Luckily for us, Java has a function that allows us to create our own type of collection of variables that can hold any number of different types of variables that we predetermine and pellet to. For example, we could create a type of collection of variables that holds 2 ints in a string. We could then declare any number of these collections to use in our program. When we create a new type of collection of variables, it is called creating a new class. For our purposes, the word class has a similar definition to classification, group, family, or type, because we are designing a type of collection of variables. When we design a class, we can even give the class a name. For example, our class could be called enemy, since that is what we'll be using it to represent. When we are writing our program, after we have designed a class, if we declare a collection of variables of that class we designed, it is called declaring an instance or an object of that class. In our case, when we declare an enemy, we would be declaring an instance or an object of the enemy class. Another thing that we can and must do when we design a class is name all of the variables that its instances will hold. This means that the x position of the enemy could be referenced as x position and not index 0, and the y position could be referenced as y position instead of index 1. And the name could also be referenced as name instead of index 2. Before I go show you how to actually design a class, I should also tell you that the way to reference a variable from an instance of the class is to type the name of the instance followed by dot the name of the variable. And I should also tell you that you can use and change the values of the variables this way. Another essential feature of classes is that once they have been designed, they're considered to be data types. So you can actually create methods which take in instances of specific classes as parameters, and you can even create array lists designed to hold instances of a specific class. Furthermore, instances of specific classes are considered to be variables. Now, I will show you how to design a class. The way to do this, how to design a class in a way that the computer can actually read this design and then allow you to create instances of it. So the way to do this is to create a new file where the class will be defined. And when I say create a new file, I mean a new file, not a new REPL. I mean to create a new file in the current REPL. And name the file whatever you want the class to be called, followed by the words .java, like so. So I go over here to Files, I click Add File, and then I select a name for it, so I type enemy.java, because each class has to be followed with .java. And also note that in Java, class names cannot have spaces, and each word, including the first one, should start with a capital letter. Next, after you have created the file, open it up. Yeah, like that. Now I have it open. It should be empty. So open it up and type the words public class, then the name of the file, except without the .java at the end. Open curly bracket, new line, close curly bracket. Type this into the class definition file. Now, between the curly brackets, we will be defining the variables that the instances of the class will hold by typing for each variable public, insert variable type here, insert variable name here, equals insert a value here, semicolon, like so. So I type, for instance, public int x position equals This is 0 for the default value. Or public int y position equals 0, semicolon. Public string name equals empty string. Now the word public is in fact relevant here, so you must use it for now and add it before all variables that have the word static before them in the main program file as well. So you're going to want to use the word public before all variables that you declare in a class, and you're also going to want to add it before all variables that have the word static before them in the main program file. And the word public always goes before the word static. So I'll be explaining what happens exactly if you do not use the word public later on, but for now just pretend that it causes a crash if you don't. Do not add the word static before variables declared in classes. Also, do not try to declare array lists or colors in classes yet. I will get to why you can't yet and show you how to modify the class so that you can do it before the end of this video, but I can't do that now. Furthermore, the variables in classes or the main program file that are declared with the words public and/or static, more specifically the ones that are not declared inside of method bodies, these variables are called fields, not variables. The only variables that are actually supposed to be called variables are the temporary ones declared inside the bodies of methods. These are the ones that erase themselves at the end of whatever body they're declared in. Also, remember that for the time being, all fields and method declared in the main program file must have the words public static before them, and everything declared in other classes must have the word public, but not the word static. I'll explain the significance of the word static later. Now, the next thing I will tell you about is the many ways to declare instances of a class. The first way is to simply type into some block of code that actually gets run, that's found in the main file, class name, the name that you want the instance to have, equals new class name, open round bracket, close round bracket, semicolon. If you declare the class this way, the fields of the instance you create will all start out having the default values that you assigned them in the class definition. If you want to set up a process for creating a class through which the programmer creating the instance of the class can assign values to the fields of the instance they are creating, you define a method in the class definition called a constructor method. A constructor method can be called by creating an instance of the class the same way one normally would, except also entering parameters between the brackets. In fact, when one creates an instance of a class without putting parameters between the brackets, they are just calling a default no parameters constructor method that all classes have. To define a constructor method, do so just like you would define any other method, except define it inside of the class definition file between the curly brackets. The word public must be added to the first line of the definition, and the return type and name of the method are both just the name of the class. So the name of the class only needs to be typed once for the definition of the method, like so. I'm going to create one now. Public. Normally we'd have the return type followed by the name of the method here, but those are both just the name of the class. So enemy, just once. Open round bracket, close round bracket, just like with a normal method. But then we would put the parameters in here, but I'm not going to bother to do that just yet. Open curly bracket, close curly bracket. Also note that because this is being defined outside the main program file, we don't add the word static. Now think of the way the method runs like so. The instance of the class is created before any of the code that you add between the curly brackets is run, and then that instance is returned after all the code that you add between the curly brackets is run. So any code you add can change the values of the fields of the instance directly by name of field with no need for instance name dot field name. So now I'm going to show you an example of me changing the value assigned to a field. So I'm going to type, we're going to make it take a parameter. So int x, that's the temporary name I'm going to give it. And then I'm going to say x position equals x. And there's no need to type instance name dot x position because first of all, we don't know the instance name when the constructor is being run because we haven't returned the instance and assigned it to a variable name, first of all. And second of all, when you write constructor methods, you can just write the names of fields and it knows that you mean this field of the instance that we're currently creating. So let's just finish this method off now. Hang on. Int y position equals y. Now I'm going to show you how to call this method here. So we go back to the main program file, and I've already explained to you how to do this. I'm just going to show it now. So we go down to some code that actually runs, or we don't even bother. We could just declare it as a field instead of a variable. So we go public static, just because it's a field, then name of the class, so enemy, instance name, I'll just call it test enemy, yeah, I spelled that right, equals new enemy, open bracket, close bracket, and then we have to pass it two integer parameters. So let's say 1070. Now I'm just going to quickly comment out this line because we don't need an enemy that's a field. All the enemies we're going to be using are going to be variables for this program. And now I'm just going to go through this program and edit all the code so that the game we've created works exactly the same way it did before, except it uses instances of the enemy class instead of int arrays to represent the enemies. So now I'm just going to do that. So the first thing we need to change is up here. We change this from being an array list of int arrays to an array list of enemies. Change int array to enemy. And then we just need to go down to all the parts where we assume that int arrays are in this and change it to assume that enemies are in it. So, okay. So here in this method, make player move, the program already contains some code that assumes that the array list called enemies contains int arrays instead of instances of the enemy class. So we're just going to quickly change the code so that enemies.getSomething at index 0 is changed to enemies.getSomething.xPosition, and enemies.getSomething at 1 is changed to enemies.get that same number dot y position. So now I'm just going to go ahead and do that. So I go Control F, enemies.get p at index 0. Then I'm going to go replace all with enemies.get p.xPosition. Then I'm going to go enemies.get p at index 1 and change it to enemies.get p.y position. Okay, cool. Now I will continue. So if I scroll down, I think this method is fully handled. I think that's the only time that we talk about the items that are found in the array list in that method. Okay, so now we're here at this enemy move method. Again, we're assuming that the items found in the array list are int arrays, or at least arrays of some kind, so that we can get something at index 0. But we can't do that anymore because instances of the enemy class are not arrays, they're instances of a class. So we need to replace enemies.getK at 0 with enemies.getK.xPosition and enemies.getK at 1 with enemies.getK.y position. So now I'm just going to do that. Also note that I use the counter named P in my loop here, in this for loop, to check if an enemy is on the same space as another enemy, so that the enemies will not end on the same space any given turn. But because I used the same counter name here as above, like in the previous method, player move, when I changed enemies.getP at 0 to enemies.getP.xPosition, it actually changed it in this method and the above method, but it might not work that way for you. So you might need to change this as well. So if you use like X, for instance, you'd have to go enemies.getX at 0 change to enemies.getX.x position. But at any rate, I don't have to do that. Take note that most of the things you will need to change in your code to make it work with classes are just loops that loop through the array list of enemies and deal with the enemy's coordinates. All you should need to do is replace all the statements like enemies.getSomeLetter at index SomeIndex to enemies.getSomeLetter.SomeFieldName. Now I'm just scrolling down to the next such loop in my code. Okay, so here I've used the counter called I, so again I just have to change enemies.getI at index 0 to enemies.getI.x position, so now I'm just going to do that. Okay, that should fix that issue. Moving on. Okay, so it looks like the last thing we have to change is this spawner code, and all we have to do is change this code from creating a new int array to creating a new instance of the enemy class. We can even leave this line because it just adds whatever we created up here. This line adds that to the array list. So we can leave this because we can call the instance of the class that we create en. So I'm going to go down a line, comment this out, and I'm going to go enemy en equals new enemy, and then I'm just going to pass these same parameters I used last time so that the enemy spawns at the same position as it spawned before we made these changes. And then I'm going to do the same thing in the other little bit of spawner code. Enemy en equals new enemy with these coordinates here. I'm going to comment this out. Make sure to add my semicolon, and the code should work. Let's see if it works. Okay, here we go. It looks like it's working. Now, I won't bother to make the computer give random names to the enemies and have it print those names out when the enemies die, because it isn't a feature that I think we really care about. It's just something I came up with to demonstrate a case where classes might be useful. If you're hoping to edit your code to work the same way as mine so that it uses instances of classes instead of using int arrays, now's probably a good time to try to do that. If you can't remember any details, feel free to rewind the video to look at the parts where I go over whatever you can't remember. But now I'm going to move on. So next, I would like to tell you that you can define multiple constructor methods for a class. And the way the computer knows which one to use when it sees an instance of a class being created is it can tell which parameters are being passed and the order they're passed, as well as what types those parameters are of. So if you have multiple constructor methods defined with different types of parameters, the computer will know which one you're calling when you create a given instance of a class based on what types of parameters you pass to it. Like if you have one constructor method that takes a string and an int, and another that takes just a string, and you create an instance of the class where you pass the constructor method a string and an int, it will know that you're calling the one that takes a string and an int. In fact, if you create one method that takes a string followed by 2 ints, and one that takes 2 ints followed by a string, it will even know which one you're calling based on the order you put in the parameters of the different types, even though you have the same number of parameters of each type. Here, I'll go show you. So I go to find another constructor method. Public enemy int x, comma, int y, comma, string n. I'm actually just going to go up here, modify this one as well. String n. And then I'm going to go x position equals 60 times x in brackets plus 10. So basically what this does is it means that this integer that the programmer passes is the x position given in spaces, not pixels. If you call this method here, but if you call this one here, the integer x that you pass defines the x position in pixels, not spaces. So we can do the same thing for the y position. equals, I think it's 70 plus 60 times y, semicolon, and then name equals n. And I'm also just going to modify this one to set name to n. And I just realized one thing. Because I added another parameter to this method here, this method in its old form is no longer going to exist. And what I mean by that is there is not going to be a constructor method for this class which takes only 2 ints. Now there's only going to be a constructor method which takes 2 ints followed by a string, and a constructor method which takes a string followed by 2 ints. And as a result of this, all of our calls to the old method in the other file that just take 2 ints are going to cause a crash unless we modify those calls by passing them a string as well as 2 ints instead of just 2 ints. So I'm going to go do that now. Here, I won't even bother showing that to you. I'll just do it like off camera. Oh, no, hang on, there's only 2. I'll just do it on camera. So, anyway. First one, this one up here, I'm going to change to the new version of the old method. Before I do that, however, I would like to notify you that these something.class files you can just ignore. And also this nohup.out you can just ignore. Only main.java and classname.java files are relevant for now. But anyway, I'm going to change this method call to be a call to this method. So I have to add a string before these numbers. So I'm just going to say Bob. And then this one I'm going to change to be a call to the other method. So I'm just going to add a name Joe. And the other thing I'm going to do, I'm just going to change these numbers to represent the position I want in spaces instead of pixels. So I'm going to go 3, 6. Oh no, hang on, sorry. In order to hit this space, we would need to go 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6, 7. Okay, now let's see if this works. Okay, so obviously we fixed it up to the point where it didn't cause a crash, but I should run the game now just to make sure that the enemies actually spawn at the right points. Because another possibility is just that like the method doesn't cause a crash, but I just gave it the wrong numbers, so an enemy is going to spawn between spaces and try to move towards the protagonist, but because it will never have the same coordinates in pixels, because it can only jump by increments of 60, it will never hit them. Here, I'll show you what I mean if it doesn't work, and if it does work, just don't worry about it. So it looks like there were some mistakes made on my part. Oh, no, they appear to be spawning on the spawn pads. Yeah, that one, this one here spawned on the spawn pad. Let's just see if the ones that spawn on the other position actually appear on the spawn pad. Oh, there we go. It appeared on the spawn pad. So you see, it worked. It knows which method to call. Because if it had not known which constructor method to call, based on the parameters I passed it, it would have either given us a crash because it would have said the name was in the wrong spot, or it would have tried to put enemies at position pixel 4, pixel 7, or space 70 plus 60 times 4, or space 130 plus 3 times 60. And it didn't. It put them at the correct spaces. It put them at space 4, space 7, and pixel 70 plus 60 times 4, 130 plus 3 times 60. So we know that this version of the program that has multiple constructor methods worked. Now we're at a pretty good time for you to try to add a second constructor method and have it actually get called yourself if you want to. So I encourage you to go do that now if you want to. So, moving on. Now I would like to inform you that you can define non-constructor methods inside a class definition file. You might be wondering why we would be able to do this, or how doing this would even be any different from defining a method in the main program file. The difference in meaning to the computer between a method defined in the main program file and a method defined in a class definition is that a method defined in a class definition is called with the syntax insert name of an instance of the class here dot insert method name here. So that's only 2 words with a dot between them. And anyway, the method can change the values of the fields of that instance directly by just the name of the field rather than by the name of the instance dot the name of the field. So inside of a non-constructor method that's defined inside of a class definition file, you can change the values of the fields of the instance of the class that the method is being called on, the same way that you can change them inside of a constructor method. As for the reason that we would do this, it is readability. If we were calling a method that only changes the values of the fields of one instance of a class and doesn't change any other values or do anything else, then it's generally more readable to define that method in the class definition file and call it from an instance of the class instead of doing the alternative, which is passing the instance that we want to change the values of the fields of to a method defined in the main program file as a parameter, like the instance is a parameter being passed to the method. So you may be confused by my suggestion that you can change the value of the instance by passing it as a parameter, because I suggested never to change the values of parameters over the course of methods in a previous video, because some types of parameters' values remain unchanged after the method finishes, and others can actually be permanently changed by methods. But now I will inform you that if during a method you change the values of fields of an instance of a class that you pass as a parameter to that method, then those fields' values will remain changed after the method is finished running. If you find that last explanation confusing as to why you are able to pass an instance of a class to a method as a parameter and expect the fields of that instance of the class to remain changed after the method is done running, don't worry if you find that explanation confusing, because I encourage you to just change the values of fields of instances of a class by calling methods from that instance instead of passing that instance as a parameter to a method defined in the main program file anyway. However, there are absolutely no circumstances where we actually need to change field values of instances the way I recommend. It can always be done the other way, so you don't actually need to define any non-constructor methods in a class. Something else you should take note of is that similarly to the way we write references in the main program file to fields from classes by typing instance name dot field name instead of just field name, we reference fields from the main project file in code written in methods outside of the main project file by typing main.fieldName, not just field name. Now, to show you an example where this capability of defining non-constructor methods in classes might be helpful despite not being necessary, I will move the enemy move method over to the enemy class from the main program file. It's like I'm going to physically move the code there, and then I'm going to edit all the code so that it will still work. So now I'm just going to do that. So I'm just going to go find the enemy move method. Okay, got it. Now I'm just going to Control X, Control V it into the other class. All right, here we are in the other class. I've cut the enemy move method. I'm just going to paste it into this class now. Okay, and now I'm just going to edit it so it still works. So the first thing I'm going to have to do is get rid of the word static. And the next thing that I'm going to have to do is replace all of the enemies.getk.sum variable with just that variable, or sorry, field, not variable. And the reason is we don't need to give the instance name here because it's defined in this class. So we're going to be calling it from an instance of the class. So I go Control F. Actually, I'm just going to do this off camera. Done. Now I'm just going to do it for the Y position. And that's done. Also note that in the part where I loop through the list to check if an enemy is on the same position as another enemy to see if it has to move back, I'm not actually going to be getting rid of the variable P, or sorry, I'm not going to be getting rid of the variable K, even though the original purpose of this variable was only for the method to know which enemy it was moving. We still need to keep it because if the computer doesn't know the index of the enemy that it is currently moving, it won't be able to prevent this from happening. We want this to happen instead. In other words, we keep the variable k because the enemy needs to know its index in the array list to make sure it doesn't move back because it's on the same space as itself. Now I'm just going to go change the method call in the main program file so that it will call this method the way it's set up here. So I go over to the main program file and scroll down to the place where we call the method. Okay, here it is. So now instead of saying enemy move I, what we would do is we would just say enemies.get I dot enemy move, and then again we still actually need to pass in the enemy's index as a parameter just so it can check if it's on the same position as other enemies correctly. Now I'm just going to run this code and test if it works. Okay, so as you can see we got a whole bunch of errors, and I know what at least what part of the problem is. First of all, and I think this is the only problem, we didn't say main dot the fields from the main program file. We just said the name of a field from the main program when we were referencing a field from the main program file. So I'm just going to have to go change everything to say main dot insert the name of the field from the main program file here. I'm actually just going to do this part off camera as well. Okay, I think I'm finished with that now. I'm going to run the code and see if it works this time. Not quite. I forgot to change the variable y to main dot y. So I'm just going to do that now. Okay, now let's see if it works. Okay, looks like it's working now. All right, just going to test it real quick. All right, looks like it's working to me. So let's move on. Now I'm going to discuss the significance of the word public and just some things that happen in relation to it when you use it in the declaration of fields and methods. So in general, when you don't use the word public before the declaration of any method or field, then you are supposed to use the word private instead. And I admittedly don't know exactly what happens when you don't put either word and you have classes in your project. But anyway, if you use the word public, then the field or method that you're defining can be accessed by code written inside or outside the class definition or main program file, if that's where the definition is being written. So for instance, because I've called this public int x position in the enemy class, it can be accessed here from the main program file. If I say enemy.xposition over here, like insert the name of an instance of the enemy class.xposition, it will be accessible. Now, if you put the word private, so if I were to have said private int x position over here, then the field or method can only be accessed by code written in the class where the private method or field is defined. For example, if I made the name field of the enemy class private, then I would not be able to write a print statement in the main program file that prints out the name of an enemy. I could, however, create a public method in the enemy class that prints out the name of the skull, so like a public method called printName, with just a print statement that prints out the name inside of it, and then I could access this method from the main program file, which would cause the program to behave exactly the same way as if I had simply made the name field in the enemy class public and written the print statement in the main program file. So why would we ever want a field not to be accessible, you might ask? To explain the reason, I think I need to give an example. Suppose we were creating a very complex game that is multiplayer and has no computer-generated enemies, so the only creatures in this game are players and they're represented by instances of a class called character. Suppose this game had 7 different types of damage. For example, fire, magic, and blade. Those could be 3. And for each of these types of damage, there would be a type of damage resistance that a character could have. For example, fire resistance, magic resistance, blade resistance, that results in the initial amount of damage that should be dealt to decrease by some amount before it is deducted from a character's HP. So the more blade resistance a character has, the less damage they take from blade type attacks. We would probably create a method in the character class called takeDamage, where The parameters you pass it are an int indicating the raw amount of damage dealt, and a string indicating the type of damage dealt. The method would be called when a character is hit, and would check the character's resistance to that type of damage, and decrease the raw amount of damage by some number that it determines, based on the damage receiving character's damage resistance to the type of damage they are receiving. And then the method would subtract whatever is left of the raw damage from the character's hit points. Because there are so many factors to be considered when determining exactly how much damage a character should receive in this example that I'm talking about, it would take a substantial amount of time to create the take damage method. Because the only way that any character's HP should ever decrease in this game is through this method, we don't want programmers working in the main program file, that includes ourselves or anyone else who is working on this project in the main program file, we don't want them to decrease a character's HP directly by just saying some character's name .hp minus equals 10 or something. If programmers can't access the field directly, then they have to call the take damage method, so they don't have an opportunity to forget to check damage resistance and any other factors. Now, the reason to declare a private method in a class is just to hide public method code that already works away in private methods to make public method code more readable. You move code from public methods into private methods and then substitute a call to the private method into the public method where the code that you moved into the private method was located. You do this for the same reason that you create any methods in the main program file and have calls to them in the main method instead of just putting those methods' code directly into the main method. Because having all that code just sitting in the main method results in unnecessary clutter and decreased readability. The same thing goes if you have like 100 lines of code in one public method. You're going to want to disperse some of that code out into private methods and then just have the public method call those private methods. Everything will be much more readable that way. Now that you know this, you can feel free to change some of the methods and fields you've declared to private, if you would like to do that. Next, I will discuss the purpose of adding the word static before the declaration of a field or method in a class. You may be confused by my doing this because the word does not appear anywhere in the only class I've created, and it does appear in the main program file. Do not worry about these things right now. Just follow along and it will all make sense. When we do not include that word before the definition of a field in a class, then each instance of that class can have a different value for that field. If we do include it, however, then the field is not accessed by typing instancename.fieldName. It is accessed by typing classname.fieldName, and there is only one value for that field. There are not as many values for that field as there are instances of that class. There is just one value for that field. A circumstance where we might want a static field is if we are creating a field that tracks the number of instances of a class currently in existence, as individual instances of the class would not have independent values for this. However, for things like HP or coordinates, it definitely does not make sense to use a static field, because individual instances of the class need to have independent values for each field. When we declare a static method in a class, it is called by classname.methodName, open bracket, parameters, close bracket, and can change only the values of the static fields of that class. When we declare a non-static method in a class, that method can change only the non-static fields of instances of that class, and is called by typing instancename.methodName, open bracket, any parameters, close bracket. Because fields and methods declared as static operate independently from all instances of the class, and can be used even if there are no instances of the class that have been declared, it generally does not make sense to declare both static and non-static methods and fields in the same class. As a general rule, any given class should have either static fields and methods or non-static fields and methods, but usually not both. There are quite a few exceptions to this, however, but the most common one is definitely when we want a class to have a variable that counts the number of instances of that class currently in existence. That's like the super common exception. There are quite a few other ones, but they're much rarer. So there you go. That's basically everything I'm going to tell you about the word static. It's basically everything there is to know. So now I'm going to give you a super shallow dive into a topic called class hierarchies, going over only the parts of the topic that I think are relevant to the things we want to do. If you hear this explanation and you want to learn more about this topic, please either go learn it from a different source or let me know in the comments below my videos and I will create an entirely separate video on this topic alone. Also note that I cannot discuss the purpose of this topic until I am most of the way through it, so don't be concerned by the fact that I'm about to spend quite a few minutes just reciting seemingly pointless facts. They will all make sense and have their purpose clarified at the end of this rant-ish thing I'm about to go on. Anyways, here I go. In Java, we can do something called making one class the subclass of another class. Alright, hello there again. Sorry to have switched to a Word document in the middle of a video. I've just realized that this is probably going to be a faster way to demonstrate classes than editing in those text boxes. So I'm actually just going to do this now since I'm not really doing anything with REPL anyway. So, an example of a class being the subclass of another class, we could make the class, for instance, small be the subclass of, for instance, class big. If it were the case that the class small was the subclass of the class big, then the class big would be the superclass of class small. A class can have many subclasses, but only one superclass. For instance, class small has only one superclass, which is class big. A class big could have many other subclasses, such as classes called medium, tiny, or almost as big. When a class is the subclass of another class, the program behaves as if all the public fields and methods that are not constructor methods of the superclass are defined in the subclass without the programmer having to define them there. So this, in this case, this method, because it's a public method, the computer would behave as if this method were defined up here in the superclass, as well as down here in the subclass, without the programmer having to actually define it in the subclass. And this field here, because it's public, the computer would behave as if this public field up here were defined up here in the superclass and down here in the subclass, even though it's not defined in the subclass. And this private method, the computer would behave as if it were only defined in the superclass, because the subclasses do not get private methods of their superclasses. And then this private field here, the computer would also behave as if were only defined in the superclass, because subclasses don't get their superclasses private fields either. And then if there were a constructor method down here, which I won't bother to define, that would also not be treated as if we're defined in the subclass too. It would be treated as if it were only defined in the superclass. So the subclass can also have additional public and private methods and fields that the superclass does not have. And the superclass can have private methods, constructor methods, and private fields that the subclass does not have. So, for example, the superclass would not have this method that's just called method, because the superclass does not inherit anything from the subclass, and the superclass would not have this method, this field, or this field, even though this method and this field are public. The superclass still doesn't get them, because the superclass doesn't get anything from the subclass. So anything defined in the subclass, only the subclass has. And then while the subclass would get these two things, this method and this field that I have highlighted right now, from the superclass, it would inherit these. The superclass gets to keep them as well, but the subclass would have them too. The subclass would not get this method because it's private, wouldn't get this field because it's private, and it would not get this public method because it's a constructor method. If you're wondering how subclasses get their constructor methods, you just define the constructor method in the subclass. One extra detail you need to know is that you need to begin any subclass constructor method with one line that just says super open bracket close bracket semicolon. And the class that you want to become the superclass needs to have a constructor method that takes no parameters and has no code in it. But back to what I was saying before, the superclass has all of these methods and fields that the subclass does not. But if I were to define more public methods or more public fields in the superclass, the subclass would immediately get them, because that's just the very nature of superclass-subclass relationship. So it's impossible for the superclass to have public methods or fields that are not constructor methods that the subclass does not have. Now, the purpose of the subclass and superclass function is to avoid repeating code that you have already written when you are creating a class that is supposed to have almost everything that another one that you've already created has, and more. So if we're creating this class called small here, that's supposed to have everything that this class called big here has, or almost everything, and it's also supposed to have more stuff, then it makes sense to have the class small be a subclass of the class big. And the purpose of this is to avoid repeating code, because if you want to have a method here called do something, and you already have one here, then you don't want to have to repeat all of the code for the method do something. You just want to say this class is a subclass of that one. Now, the next thing I'm going to teach you is that a subclass can have a method defined in it that has the same name and takes the same parameter types in the same order as a method defined in the superclass. So for example, I'm going to add new methods to both classes now, and I'm going to put them in a bigger font so you know which ones I'm talking about, which ones I just added. So this is what I mean. The method I'm referring to in this case is the one that's called over method. See how I've defined it in both classes? Also note that they both take an int and a string parameter in the same order. You need int string for this over method and int string for this over method. So if we had an instance of the class small that we created in the main program file, so you see here this new text box I've created that's supposed to represent the main program file. So we create an instance of the class small called dwarf, and then we call the over method from dwarf. The computer would know to call the over method of the small class, not of the big class. This method overrides that one. So it's going to print out on the first line the name and then the number that you pass to the method. Oh, I suppose I have to pass a number and a name to have this make sense, don't I? Okay, let's say 5 Bob. Okay, sorry about that. So because we're calling the subclass version of this method over method, it prints out the name that you pass followed by the int. So this would print out Bob on the first line and then 5 on the next line, dwarf.over method. But if we were to declare an instance of the big class, so if we said big giant equals new big, and then we said giant.over method 5 comma Bob, then it would print out 5 on the first line and Bob on the second line, because giant is an instance of the big class, whereas dwarf is an instance of the small class. So it would print out the int followed by the string, because it's calling the big class definition of the method over method rather than the small class definition of the over method. So when the subclass definition of some method gets called, when that method is also defined in the superclass, that is called overriding the superclass method. Now, one more important detail about superclasses and subclasses is that instances of subclasses can be placed in a list of instances of their superclass. However, we could not put instances of the superclass into lists of the subclass. So for instance, if we were to go like this, and to declare an array list designed to hold instances of the class small, and another one designed to hold instances of the class big, and then we declared an instance of the class small and of the class big, and then we tried to add an instance of the class small to the array list of instances of the class big, this would be okay. We would get no problems here, because if something is a subclass of another class, the instance of subclass is considered to be a superclass. So a small is a big in this case. These examples don't make a huge amount of sense, but just follow along for now, and it will start to make more sense later. But back to our main topic. This line here would cause no problems. We can add an instance of the subclass to an array list of instances of the superclass. However, if we then try to add an instance of the superclass, so the giant, to the array list of smalls, this would cause a crash because the superclass is not a subclass. So a big is not a small, but a small is a big. So, for instance, like a better example might be with squares and rectangles, because all squares are rectangles, but not all rectangles are squares. So we could have superclass rectangle, subclass square, and if we were to try to add a square to a list of rectangles, that would be okay, because a square is a rectangle. But if we were to try to add a rectangle to an array list of squares, because the square is the subclass, we would get a crash. Now, the last thing I'm going to tell you about class hierarchies is that in order to make a class be a subclass of another class, we change the first line of the definition of the class that we want to make be a subclass. We change it to public class, whatever the class name is, extends, insert superclass name here. We don't have to modify the superclass definition file to create a subclass superclass relationship. We only modify the subclass file. Now, allow me to give you a more practical example of a superclass subclass relationship than just fictitious classes with no purpose called big and small or square and rectangle. An example where it could be useful and readable for us to make one class the subclass of another is if we wanted to make a class which represents a different type of enemy in our current game that moves 2 spaces each turn instead of 1 and is also green instead of white. So we could make the new enemy its own class that is the subclass of the normal one. Now, just to go over what it means when you make a class the subclass of another again, if you have an instance of a subclass that is supposed to be a subclass, so let's say the subclass is called upgraded enemy, and upgraded enemy is supposed to be an upgraded enemy, but also it's supposed to be an enemy, the superclass, which an upgraded enemy is. An upgraded enemy is both an enemy and an upgraded enemy. However, an instance of the superclass is not necessarily an instance of the subclass. So an enemy is an enemy, but it's not necessarily an upgraded enemy. But anyway, to create a new class that extends the enemy class that represents the new type of enemy that I've described, without actually overriding the entire enemy move method, because it's kind of pointless to even create a subclass if we're going to override the entire enemy move method, because that's almost all the code contained in the enemy class now. The way we can do this is modify the enemy move method in the current enemy class so that it uses a value returned by a new method that we define called return hop distance, which returns the number 60, and we then substitute a call to the return hop distance method into all of the places where the number 60 appears in the current enemy move method, and that way we can just override the return hop distance method in the subclass rather than overriding the entire enemy move method. So I'm just going to do that now. So I go new file, I'm going to call it hopper, because it's going to look like the upgraded enemies are hopping. So hopper.java, then I'm going to go public class hopper extends enemy, open curly bracket, close curly bracket, new line. Then I'm going to go back to the enemy class and create the return hop distance method. I'm just going to do that off camera. Okay, I've done that. Now I'm just going to replace all of the number 60 in the enemy move method with a call to the return hop distance method. So I'm just going to do that off camera now. Okay, now I've done that. So I'm just going to go override this return hop distance method in the hopper class. I'm going to do it off camera. Okay, I've done that. Now, when I suggested that we have the hoppers and the normal enemies appear in different colors, you may have wondered how we were going to do that, because I told you not to use any colors or array lists, but mainly just colors in classes yet. Now, you might have thought of the solution that is to give them both a method, like one that's overridden in the hopper class, where it returns an int, and then we call that method in the main file when we're supposed to paint the enemy, and then we pick which color to draw the enemy in based on what that overridden method returns. However, an even more direct solution is for me to just show you how to allow yourself to use colors in classes now. So I'm going to do that. So some context that you're going to need is that when the computer interprets our code, every time it sees a method call, it needs to go through a list it has of all the available methods to find one with the same name as the one we are calling. This can take a few milliseconds, which is considered to be a lot of time in some contexts. So it tries to keep the list as short as possible. As a result of this, By default, most pre-written classes, and therefore the methods in those classes that Java has, are not accessible from most classes. That way, the computer doesn't have to have as many methods stored in the list that it looks through when it tries to find a method that the programmer calls. And a shorter list means less things to look through, which means less time spent looking through it. So you can easily make the methods of pre-made classes accessible. You just have to type a command to do it, because there's no point having these things completely inaccessible, but there's also no point having them accessible and having them waste time if you have no intention of using them. So in order to make a given pre-made class accessible, simply type right up at the top of the class, before even the public class something line, type import, then the path to the class that you want to be able to use the methods from, and the path to isn't just the name. I'll get to what that is in a second. And then a semicolon. So two classes that need to be imported in order to be used are the ArrayList class, actually, and the color class. So I've actually imported these into my main program file, and I'm actually just going to go over to my main program file now and show you the import statements that I used to import colors and array lists, and then copy them into the enemy and hopper classes. So here we are in the main program file. If you look up at the top, you can see all the things I've imported. Most of these things we don't use yet. I just have them because we might be using them in the future. And I'm not impatient enough to care if the computer takes a few extra milliseconds looking through the list of methods it has. So anyway, the import statements that bring in array lists and colors are right here. This is the one for colors. This is the one for array lists. So I'm just going to copy those both real quick now and paste them into the other two classes. Okay, so I've pasted them into the regular enemy class. Now I'm just going to go do that into the hopper class. All right, now I've pasted them into the hopper class. So now that I have copied these into the hopper and enemy classes, I'm just going to really quickly modify these to have a return color method, and then we're going to use that method to pick the color that we draw the enemy in instead of just using the color.white. So I'm just going to make those methods now off camera. Okay, I made the one for the hopper class, and I'm just going to do the one in the enemy class. All right, now I've done that. So the next thing we're going to need to do is just really quickly go over to the main program file and modify the paint method to use each enemy's return color method instead of just the color white when drawing the outside of the skull. So I'm just going to do that right now. So we go over here to the main program file, we scroll down to the paint method, and here I am. Okay. So now we're just going to change all of these color.whites to enemies.getI.returnColor. So now I'm just going to do that. Okay, so that's done. Now the only thing we need to do to finish code for use is go over to the hopper class, add a constructor method because it's not going to inherit the constructor method from the enemy class, and then just change the code in the main program file to actually call that method sometimes. So now I'm just going to do that really quickly. Okay, here we are in the hopper class. So I'm just going to go public hopper. I'm going to finish it off camera. Okay, I finished with that. Now I'm just going to go change the code in the main program file to actually spawn these. So I go to the main program file, I scroll down to the part that spawns enemies. We're here now. And I'm just going to change this code to go, instead of enemy en, we're going to say hopper en equals new hopper. And then I have to adjust this to give the coordinates in pixels instead of spaces, because this method to spawn an enemy that we were calling here gives the coordinates in spaces, but my method I defined gives it in pixels. So I'm just going to do that real quick. All right, now I have done that. I'm just going to try to play the game now and see if it works. Okay, so we have some error messages. I made one mistake. I forgot to add the open bracket, close bracket after the return hop distance method call. So I'm just going to do that and see if it works. Okay, I've done that, and I'm just going to run the game again. Okay, so it actually crashed, and the reason for that is that I forgot to add a command line containing nothing except the word super at the beginning of the code for the constructor method in the hopper class, because it's a subclass, so its constructor method has to start with this. And I forgot to add a no parameters a no parameters constructor method with no code in it for the enemy class. So I'm just going to add that as well, and that should fix the problem. All right, now let's see if it works. All right, it appears to be working. All right, as you can see, it looks like it's worked. There's a hopper has spawned here, and there's some enemies up here. Let's just see if the hopper is moving the way it should. Yeah, it's just hopping back and forth across these spaces, which seems a little bit dumb, but that's not because the program's not working. It's just because we didn't program the hoppers to be very smart yet, that's all. So if you want to modify your game to work this way, now would be a good time to do it. So I'm just going to wait a second and give you some time to pause the video and do that. Okay, now I'm going to move on. Alright guys, now that you've seen all this stuff, I'm going to tell you that the main program file is in fact a class definition file, and that there are only two special things about it that distinguish it from the other classes we created for this project. The first of which is that it contains the main method. So the code for this program starts there, and the main class extends a pre-made class called JFrame, which is a class that represents a window, meaning the thing that appears on your screen through which you interact with any program, including a game or a browser, and that you can X out of when you're done with. That's what I mean when I say a window. Like this whole thing you see here with this X here, that I have, like Firefox, that I have open to REPL, this all is a browser. And this is the window for this browser, sorry. Now, because the main class extends JFrame, the paint method must be located in the main class. Now, when you're using REPL, they'll make you put the main method into this first class they generate for you into a new REPL called main.java, but if you use a different IDE to code in Java, everything will be the same, except you can call your class that has the main method whatever you want, and you can put your main method in whatever class you want. It doesn't have to be in a class called main. So if you create a project not using REPL that has a main method or a class extending JFrame, neither of those classes necessarily has to be called main, and they also don't have to be in the same class. Like the one with the main method doesn't have to be one that extends JFrame. In fact, even here in REPL, I could have had my class that extends JFrame be separate from the one containing the main method if I'd wanted. I just didn't really want to do that because I was only going to create one JFrame. So all of my fields that represent the properties of the JFrame were just going to be static anyway, so there was no real point creating two different classes. I could just put all my static fields into one class. Now, all of that aside, I made my main class extend JFrame because I needed a way to create a window somehow, and the class I chose to use to create a window was JFrame. There's other ones you can use, but JFrame was the one I picked because it's just the one I have the most experience with. And I also thought that the simplest way to edit the graphics displayed on the window that we're going to be creating for our project would be to simply override the paint method of the JFrame class rather than adding other instances of other classes to the JFrame we create and then modifying those using methods pre-existing to modify them. I thought for now it would just be easier to create a subclass of the JFrame class and override the paint method. Now, the reason that this program we wrote does not make an actual window appear is that when we write code in REPL, it just substitutes a small window up in this little top right corner here for an actual window that would display on your screen. But if we were to write this code in Java in a different IDE, then we could actually write code that would make a window display on our computer, and it would behave like its own app. Almost. It's just REPL doesn't allow us to do that with graphics in Java. So now that you understand all this stuff about classes, allow me to tell you that in order to actually have the computer do int addition, which I think is the simplest operation I have shown you so far, but I don't know that for a fact, the computer needs to be told to configure at least 64 wires internally in a very specific way, but always the same way to perform int addition. So the code that makes it configure all these wires for int addition is pre-written in a language other than Java, and Java is set up to have pre-written classes with methods defined in them that call code written in other languages that results in any and all possible physical functions inside the computer that we could need taking place. So you have to know enough about classes to use these pre-written ones to get the physical functions of a computer, but that's all you really need to know about classes. Again, like I said, you can write all your code in one class if you want. Now, the code that makes the computer do these things is not Java related and is not needed to make any app that you could ever want to make. So I will not be showing you any of this. And the only reason I'm even telling you about this non-Java code is so that you can understand that some of the pre-written classes have methods that do things that we cannot duplicate in Java without just calling these methods. And this is why I will not show you the code for these methods, because they're not written in Java. And neither of us would really understand that code. But all that aside, now I will go talk you through the starter code that we've been using this whole time to the extent I understand it, and to the extent that it can be understood with just Java alone. So if we look up at the top of the main class definition file, you'll see a bunch of import statements. So I'm just going to go up there right now. I'm going to do that off camera. Okay, here they are. So we don't need all of these import statements for our current project, but we may need them for future ones. So I decided to add them now just to save myself the time of deciding which ones we need to import when later on, and then telling you how to type them out. So moving on. If you look at the next line of our main class, you will see the class definition, including the part telling the computer that the class is a subclass of the JFrame class. So that's this line here. So on the line after that, we are creating an instance of a class called Scanner, as you can see, this here. And Scanner is a class that reads through strings line by line. And the special property of this class is that we can pass it this parameter, which allows it to interpret whatever the user types into the console as a string that it can read through. So that's what it does. We create an instance of this class so that we can use it to look through the console. I can't really explain how it does that though, because that code isn't written in Java. But as you know, we don't really need to know how it does that either, because we understand it well enough to use it in any way we want. So that's good enough. So a new interesting thing that you can know now is that if we were to change this, like these two letters from being SC to something else, it wouldn't actually cause a crash so long as we went through our code and changed everything that has an SC in it to whatever we had changed these to up here. Because this here is just the name of the instance of the scanner class we're creating. It's just a name we're picking. We can give it whatever name we want. So on the next line, this one here, you'll see we're creating an instance of the main class. The reason we need to do this, even though all the fields we added to the main class are static, is that the JFrame class has some non-static fields and methods. Therefore, the main class also has those fields and methods. So we need to create at least one instance of the main class to make use of these. In fact, now if you go look at the beginning of the main method, you'll see that I have called a bunch of JFrame methods that you won't recognize, and I have called them from the instance of the main class that I created, this instance called frame here. So now I'm going to go scroll down to the beginning of the main method and show you that code. And I'm going to do that off camera. So here we are. Now, these are the commands that I was referring to. This one here just tells the instance of the JFrame it's being called from that the way it's closed is when the X is pressed, although that's not as relevant in REPL because you don't really close this window up here. You just press this stop button. This one here just tells it what its size should be in pixels. This is the width, this is the height, and this width and height we've entered are actually bigger than this window over here. I'm just kind of too lazy to change them. So there's actually a bunch of the game we've created that runs off of this screen. But anyway, this just tells the frame to have a size that can be changed on the fly. This one tells it to start in the center of the screen, and this one just tells it that now it has been passed all the information it needs to become visible, so it should become visible. And then this one just tells it to repaint itself. So this frame.repaint, this is actually just a repaint method that I'm always calling from the instance of the main class I created, which is called frame. There. Okay. Now, moving on. If we go back up to where we declare frame and SC, and then look a few lines further down. So I'm just going to go scroll up to that point off camera. So now we look a few lines further down, and we find this line here. You'll probably notice that it looks similar to the constructor for a class called ArrayList, but it's not quite there. But what if I were to tell you that the class that this method is related to is called ArrayList open caret enemy close caret? Now you'll notice that it is in the exact format it needs to be in to be the constructor method for an instance of that class. Because look, we have public, static, class name, instance name, equals, new, class name, open bracket, close bracket, semicolon. So that's an interesting special property of the ArrayList class. Whenever you create a new class, a new ArrayList class called ArrayList open caret, the name of the class you just created, close caret, comes into an existence just to hold instances of the class you just created. And again, that's a function written not in Java. I can't teach you a way to make classes that define other classes. I don't think that's something we can do in Java. It might be though, it's just not something I know how to do. So now if we go scroll down and look at the paint method, so again I'll just scroll down to it off camera. Alright, here it is. You now understand that it has special properties written in non-Java languages, and that it is defined in the JFrame class and overridden here in the main class, and that it takes a parameter of type graphics, which I have given the temporary name G. Notice up here I said the parameters it takes are graphics G. So it's always, when we call methods in this paint method, we always call them as G dot some method name. So if I were to change this to like th or something, then I could say th.setColor, th.fillRect, etc. Another strange property of this paint method is that we don't actually have to create an instance of the graphics class somewhere and then pass it to the paint method every time it's called. So I suspect that this paint method gets the graphics parameter from the instance of the JFrame class that it's called from, but I'm not sure that that's the case, so don't quote me on that. But anyways, that's all I really need to explain about the starter code, I think. So that's it for today's lesson. I would like to notify you that you now understand the majority of what you need to know how to program in Java. So if you made it this far, give yourself a huge pat on the back. You've definitely earned it. There are still hundreds of specific topics that you don't really know anything about, but now you have the majority of the basics. So if you want to learn any of these other specific topics that you're wondering about, you'll probably be able to do so very quickly. I am now considering creating 3 more videos. One on how to export this game so you can just play it by opening a file that you send rather than having to create a REPL account and copy the code. One on how to make a game where stuff happens in real time so you actually have to react quickly. And one where I edit this game so that it saves your progress between runs. If you're interested in any of these topics, please let me know in the comments below, and I will consider creating these videos for you. Thank you very much. Bye.